Volume of cones, geometry. The essential question, how do you calculate the volumes of composite figures that include cones? The answer, break the composite figures into familiar solids, such as cones, that you have a volume formula for. Then basically you find the volume of each figure and add them. Okay, so if you were to think about previous content, if you had, let's say, a cube, and then on top of the cube they placed a let's say a cylinder. And if you wanted to find the total volume of that composite figure, you would basically have to add up the volume of the cube plus the volume of the cylinder. Right? And that would be your total volume. Same thing here with cones. Okay, of course, what is the formula for a cone? So let's find out. Okay, so developing the formula for a cone. Basically, we start off with a pyramid inside the ideal cone, okay? But just like if you remember n-gons, as an n-gon as the limit of n approached infinity, your n-gon started turning into a circle, right? Started turning into a circle, and therefore I said it approaches pi. Okay, if you remember that GIF, it slowly turns in, like here, for example, 1, 2, 3, gone. Then as it starts increasing, 4, gone. And then it keeps increasing, 5. And then eventually 6, 7, 8, 9, 10. But as you keep doing that, we approach pi. Okay, so another visual, if you want to see, looks like this. If you remember developing the n-gon and deriving where pi comes from, and basically I showed you guys that this whole thing, okay, as the limit approaches infinity, just equals pi. Okay, so again, this whole thing right here just approaches pi. So I've shown you the proof of that a while back when we were doing n-gons, okay, and trying to figure out where pi derived from. So hopefully that brought back some memories. All right, so the general formula for the volume of a cone can be represented as V equals 1/3, okay, pi r squared times the h. So again, here is the volume of a cone. So one of the things that you need to realize is the base of a cone is really just a circle. And if you remember volume, volume is just, well, what's the area of the base, because it's all about that base, no trouble. And the base here is really just a circle, so it's pi r squared. And then you have to factor in, okay, what about the height? And then this is not a full cylinder, okay? It's not a full cylinder. And that's exactly why we end up using the 1/3. So I'll tell you what, talk to your buddy. Where does the 1/3 come from by the cone's volume formula? Yes, it has something to do with the cylinder, but if you really want a quick proof, just drop by. Let me show you and your buddy, okay? And then you guys explain it in your own words on why that 1/3 exists. All right, your turn. Find the radius, then use Pythagorean theorem to find the height of the cone. So they only give you the slant height. This is what we call in the industry the slant height. Some people represent it by S, some people represent it by L, but it's not the same as the height. So you have to actually use Pythagorean to find your height. Sorry, that was a terrible, terrible H. There, that's a little better. But you have to find the height using Pythagorean. So remember Pythagorean, it's basically a squared plus b squared equals c squared. C is your, right here, your hypotenuse. And then here is actually your radius, but at the same time, it is also your A. Okay. So use Pythagorean, find your height, and once you find your height, you use the formula from the previous page. And don't forget, we're in cubic inches if you're looking for volume. So what is your capacity to the nearest fluid ounce? Go ahead and look that up. How much is in a fluid ounce? All right, how many cubic inches are in a fluid ounce? So you have to look that one up too. Do some research. You're watching this on a computer, chances are you can Google it real quick. All right, find the volume of a composite figure. So when you're finding the volume of a composite figure, we're going to combine all the smaller geometric shapes that we can identify, and then we're going to add them all together to get our final answer. So we're going to round to the nearest cubic millimeter. All right. So let's see. We have, first things first, we have the volume of a cone. It's a terrible cone. All right, the volume of the cone is on the left, okay? And it equals 1/3 pi r squared. R is, well, let's take a look. I think they say the diameter is 16 millimeters, okay? So if the diameter is 16 millimeters, then what's the radius? The radius is going to be, of course, half, so it should be 8. Don't forget we're squaring the 8. Now what about the height? We don't know the height yet. We don't know how much this is. We know that the height of the cylinder is 19, but we don't know the rest. Well, what's 32? The total is 32, right? So 32 minus the 19. All right, so if you actually just plug that in your calculator real quick, you should get 13. So our height for our cone is 13. We had to use the total and what was given to us, so it's kind of a puzzle. All right, so multiply that by 13. You can use your calculator. You do 8 squared, that's 64. 64 times 13 times pi, and then divide by 3, or multiply by 1/3, it's up to you. And you should get the volume for the cone, which is 871.26. Round up to 27 if you want. They say round to the nearest cubic millimeter. So I think they're happy with that. Also, just note, usually they want you to round at the very end. So they might have 8.7127 millimeters cubed, and then they round at the very end. So that's something to take note of. Now the volume for the cylinder, okay, we have to add them up. So let's do this. The volume of the cylinder is just pi r squared times the height. So our radius again is 8. We square that, and its height is 19 millimeters. So again, 8 times 8, 64, times 19, times pi, and you should get the volume equaling 3,820.17. And so we're going to add them up. This is millimeters, or cubic millimeters, apologies. So we're going to add them up. We're going to add up the cylinder, and we're going to add it up with the cone. So if we add those up together, you should get a total volume totes V to be 4,600. Now I'm also including my decimals in this answer on the calculator, but it doesn't go to 0.5 unless you round all the way up from the thousandths, which I won't. So this is my final answer to the nearest cubic millimeters. Okay. So again, I had to add up what was familiar to me and then work off of it. All right, your turn. So making a cone-shaped hole in the top of a cylinder. Maybe you're making a cup or some kind of, I think the engine nozzles work like that as well. So that the apex of the cone is at the base of the cylinder. So the apex, what they're talking about here, the apex is that little part. Okay, it's at the very bottom. Now find the volume of the figure to the nearest tenth. So they want you to find the cylinder's volume first, then find the figure total. So basically, you have your cylinder minus the cutout from the cone. Okay, so you have to find your cylinder first, then subtract the volume of that cone. And I think the diameter is 3.6. So the radius, if you want, just cut it in half, 3.6 divided by 2. And you should get your radius for your formulas. Okay? Let me know if you got that. Okay? All right, I think that's it. Homework, page 955 through 957, numbers 1 through 10. Let me know if you have any trouble. Good luck.